Hello everybody and welcome to today's session where we'll be talking about how to achieve global connectivity on AWS with the use of Direct Connect, Transit Gateway, and Direct Connect Gateway. My name is Germán González and I'm a solutions architect with AWS. Over the last couple of years, we've had quite a few launches in the networking space in AWS, and the purpose of this presentation is to let you know how you can bring them all together in order to provide global connectivity. We will start by having a brief introduction, also a level setting part. Then we will move on to a scenario review where we will dive deep into a few architectures. And then we will move on to the demonstration part, finalizing with the Q&A. The reason why we are looking into global connectivity is because we have seen that many customers have offices around the world, and originally they might have deployed resources on a single AWS region, but as they continue to grow, they have deployed resources in multiple AWS regions, and they want each one of their offices to be able to reach them in the most effective way. We have also seen that there are more and more workloads being migrated to the cloud, and this means that even if the company does not have global presence, they might be deploying in different regions in order to better serve their customers. And the third reason is because we have seen that many companies also have realized that they can use the AWS global backbone in order to use it as communications instead of having specifically lines or other connectivity methods. This is something that is very easy to set up, very easy to achieve, and it has high throughput and low latency. So to begin with, I'd like to address the different types of virtual interfaces that we have so that throughout this conversation this is not confusing. And the first one that we have is a private virtual interface. This one is used to connect through Direct Connect to the Amazon VPCs in a private manner. So all of the IP addressing is private, as the name implies. We have the Transit VIF, which is the most recent type of virtual interface, which is used to connect to a transit gateway via Direct Connect Gateway. And then we have the public virtual interface, which is used to access all AWS public services through public IP addressing. So as you may see, these three different types of interfaces have a different purpose. And on a single Direct Connect dedicated connection, we can have up to 50 connections, up to 50 virtual interface. And we can have also one transit virtual interface. If you have a hosted connection, then you only have one virtual interface, and you need to decide which type you will launch. So the first type of interface is a private virtual interface. In this case, we have a customer router on the corporate data center. Then we also have a customer router in the Direct Connect location, which will be physically linked to the AWS router. This virtual interface will be attached. Originally, it was attached to a virtual private gateway attached to a VPC, but after the launch of Direct Connect Gateway, this is the preferred way of doing so. So we can directly connect to the Direct Connect Gateway, and we can have more scalability, and we can also have global reach. When we were attaching directly to the virtual gateway, to the virtual private gateway, we were limited to doing so only in the region in which the Direct Connect connection existed. But with the use of Direct Connect Gateway, we can reach any region in the world except China. In the Transit Virtual Interface, what we are doing is very similar, with the exception that we are now connecting the Direct Connect Gateway to the Transit Gateway. So this allows for even more scalability, and we can use the Transit Gateway to connect or to provide connectivity among the different VPCs. And the Direct Connect Gateway will provide also connectivity between on-premises and the AWS resources. It's very important to note that the Direct Connect Gateway only allows north-south connectivity. And by this, I mean that it allows the traffic flows that go from the data center to the cloud and vice versa. But we are not allowing traffic from different interconnected VPCs to the Transit Gateway, to the Direct Connect Gateway. And for that, we need the Transit Gateway. In the case of Direct Connect Public VIF, what we have is a publicly addressable IP space. And from that IP space, we can reach the different services that are available in AWS, but we can also reach the endpoints for the VPNs. And that is the reason why we are mentioning it in today's conversation, because we will be talking about how to reach this global connectivity through IPSec VPNs. One of the reasons, or one of the ways in which customers start deploying resources on AWS is by first just deploying a single EC2 instance or a few EC2 instances, which may or may not have public access. But even if they do, the customers need a private way in which they can access them for management purposes or because it's being used internally. So in this case, what we can do is to use the customer router to set up a VPN towards the virtual private gateway, and in that way establish a private secure channel. Once we have deployed these resources and we want to start deploying more resources for other departments of the company or for different projects, we might decide to create additional VPCs. And in these additional VPCs, if they are only a few, we can use VPC peering to interconnect them. But as we continue to create more and more VPCs, the preferred way of interconnecting them and the more scalable way of interconnecting them is through AWS Transit Gateway. In this case, the AWS Transit Gateway will also be terminating the VPN from the customer side, and that means that the customer doesn't have to create VPNs to each single VPC, but they can concentrate them directly on the Transit Gateway. Once a customer keeps growing and now decides to launch more and more resources within AWS, they might decide that they need a link that provides a higher throughput and a lower latency. And for this, they decide to go through a Direct Connect connection. In this case, they decide to create a public virtual interface so that they can keep the same connectivity method through IPSec VPNs, and in that way reaching the Transit Gateway through the Direct Connect connection and through public IP addressing. But again, the secure channel is established, and that is the way that can allow them to have a secure, private, and high-performing connectivity. Once you have reached this point, the company may decide that it's going to launch different services in different regions, and now it's time to rethink the strategy. Now it's the right time to say, okay, what am I going to do in the future? How am I going to cover the future needs? And what is the connectivity strategy that I will be following? And for that, I have taken into account 4 different scenarios. These scenarios will be using the different types of VIFs depending on the customer requirements. And the first one is a VPN to AWS Transit Gateway using Public VIF, which is the one that we just saw. We will also touch upon how to do a VPN to a Transit VPC using a private virtual interface. The third scenario is how to connect a single Direct Connect gateway for multiple regions using the Transit VIF. And the fourth one is using a unique Direct Connect gateway per region using the Transit VIF. So, for the first scenario, what we have is multiple sites, and each one of them has a Direct Connect connection. In this case, ideally, this would be redundant Direct Connect connections per site. And we can establish a public virtual interface. Through this public virtual interface, we will establish VPN tunnels directly to the Transit Gateway, and the Transit Gateway will be connected to the different VPCs. So the Transit Gateway is a regional construct, so it will only be able to connect to the VPCs that are existing in the same region as it is. And in order to connect to the other regions, we will take advantage of Transit Gateway Inter-Region peering, which will allow us to communicate from this region to the one in the bottom. This architecture will allow both corporate data centers, the site on the top and the site on the bottom, to communicate with resources in any region of AWS, but it will also allow them to communicate with each other because they are both performing a VPN through the Transit Gateway, and they can use the inter-region peering in order to reach each other. So this is a method that is very simple to implement that allows connectivity from both the sites towards the regions, but also from site to site. Some considerations when using this approach is that it's fully encrypted into the AWS network, so that is something very important to take into consideration. But also, we need to secure the public virtual interface. The public virtual interface is receiving the ranges from all of the AWS public services, and that includes EC2 instances. So it's important that you secure this interface as if it were internet-facing. This approach does not require management of EC2 instances since all the VPNs are being terminated on the transit gateway, and it does provide site-to-site and region-to-region connectivity. So in this case, we can allow everybody to communicate, or all the different sites and regions to communicate with each other. The IPSec tunnels have a limit of 1.25 gigabits per second per IPSec tunnel, but we have the capability of deploying equal cost multipathing, and in that way, we can increase the performance of the VPNs. The next scenario is the VPN to the Transit VPC using a private VIF. This scenario is covering a very specific need, and that is when a customer wants to perform a VPN towards a private IP. So in this case, what we have is a customer router that is establishing a private virtual interface. And this private virtual interface is being linked to a Transit VPC. Through this Transit VPC, we can reach privately the EC2 instances which are running third-party software and which will be terminating the VPNs. These instances can then perform their own VPNs throughout to the Transit Gateway, or they can also have some other reachability method, such as a VPC attachment. So the decision on how to perform that or which to choose is dependent on the customer requirements, but this is another thing that we could, or another approach that we could have. Once we get to the Transit Gateway through inter-region peering, we can also get to the second region and that way have full connectivity. This method also allows both corporate data centers to communicate with both regions and also to communicate amongst each other. So again, this is also an architecture that will allow all the different sites and regions to communicate with each other, of course, if we allow it to do so. I mean, if the internal policies require that some sort of communication is blocked, that is something that can definitely be done. Some of the considerations with this approach are that the traffic is also fully encrypted into AWS. In this case, there is no need for securing the public virtual interface because all of this will be performed through the private virtual interface. It does require management of EC2 instances with third-party software. And we need to take into consideration the bandwidth limits for the instances. So in this case, we have bandwidth limits for the type of instances, but also the software itself might impose some sort of limits. So it's very important to test this before deploying so that we know what to expect. This scenario does provide site-to-site and region-to-region connectivity. And the Transit Gateway provides the attachment to the VPCs and also the cross-region peering for connectivity with the second region. The next scenario is where we have a single Direct Connect gateway for multiple regions using a Transit virtual interface. And in this case, what we have is a corporate data center connecting through Direct Connect to one of the AWS routers, and then we can create a Transit virtual interface, which we will then attach to a Direct Connect gateway. This Direct Connect gateway has again, the Direct Connect gateway is a global construct, so we can reach VPCs and transit gateways all around the world. And in this case, we're going to link it to both transit gateways. We're going to link it to the transit gateway in Ireland, for example, and a transit gateway in Sydney. That could be an example. And in this case, we will be able to have reachability to both regions. It would not allow the connectivity from one site to the other if we wanted to communicate from the top data center to the bottom data center. This is not a traffic flow that would be enabled by the Direct Connect gateway. But in that case, we would need to cover that need by having some sort of private connectivity between those two data centers. Once we have arrived at the Direct Connect gateway, then we can go to a transit gateway, and that will enable connectivity to the different VPCs. And in this case, both data centers can access resources in either region or in both regions that we are deploying these resources. In this case, I am only depicting 2 regions, but this could actually be 3. It could not be more than 3 because of a restriction that we will see in a moment. But this is one of the architectures that I would find to be most interesting and that can benefit the most from the global backbone of AWS. Some of the considerations of having this approach is that the Direct Connect gateway has a limit of 3 transit gateway attachments, and in this scenario, this would map to a maximum of 3 regions. So if we want to connect more than 3 regions, we would have to take a different approach. In this case, we are not providing site-to-site connectivity through Direct Connect Gateway, but it does provide a minimum latency because it traverses the least amount of elements that are going to process the traffic. So this is why the latency is the lowest in this case. And we can have up to 30 virtual interfaces per Direct Connect Gateway, and that maps to the total amount of sites that we could connect using this approach. If we have redundant sites, then well, we would have a maximum of 15 sites connected redundantly to the same Direct Connect Gateway. The last scenario that I want to review is the one related to AWS Transit Gateway using using multiple Direct Connect gateways, one per region in this case. So we have the data center on top, which will have its own transit virtual interface and which will connect to its own Direct Connect gateway. And that Direct Connect gateway will connect to one of the transit gateways, in this case, the one in the top region. This scenario is replicated on the bottom, and as you can see, these are 2 different Direct Connect gateways. Since they are 2 different Direct Connect gateways, that means that we can actually communicate from the corporate data center on the top to the corporate data center on the bottom through this Transit Gateway Inter-Region peering. So the traffic flow from the top would be from the customer router to the AWS router to the Direct Connect Gateway to the Transit Gateway on top to the Transit Gateway on bottom through the Direct Connect Gateway on bottom and so on in order to get to the data center on the bottom. So this architecture would allow us to communicate the multiple sites and the regions as well. Some other considerations that we need to take when designing our approach to global connectivity are the fact that we can use accelerated site-to-site VPN connections to allow an easier integration of sites that do not warrant a direct connect link. So if we have smaller sites that don't really need to connect through a dedicated connection, we can do it through a site-to-site VPN, but it's not a regular VPN. It's a VPN that will be accelerated through the use of AWS Global Accelerator, which is an Anycast technology that will allow customers to get into the AWS backbone as soon as possible, and therefore take advantage of the high throughput and low latency of the backbone. Another consideration is that when we are looking at an architecture for our use case, we don't have to follow just one of those that I mentioned, because we can mix and match in order to suit the different use cases that we might have. An easy example would be if we have a large transfer of data and we don't want to incur in transit gateway charges. So let's say we want to move our big data workload, and this is perhaps 300 terabytes of data, and I don't want that to be incurring into charges for transit gateways, so I might create a connection directly from the Direct Connect connection to the VPC. From the transit gateway perspective, we can have up to 20 routes that will be advertised to on-premises, and this is a very important limit to take into consideration. And it's also important to note that these routes can be summary routes, so we don't need to have a very large amount of routes if we are summarizing correctly. We can also have up to 20 Direct Connect gateways per transit gateway, and this is most important when we are taking into account the amount of sites that we would be connecting into each transit gateway. And we also have a maximum of 1 transit virtual interface per Direct Connect connection, and that means that if you have a Direct Connect connection, you can only be connecting to one Direct Connect gateway, which on its own will be able to connect to 3 transit gateways. So it's time to move on to the demo, and this is what we're going to do. So here we are at the demonstration, and basically what we are going to do is that we are going to set up an infrastructure that will allow us to communicate globally with 2 regions. These 2 regions in this case are Ireland and Sydney, and I have already set up a part of this in order to build upon it. And what I have done is the following. I have created a VPC on the Ireland region with the CIDR of 10.1.0.0/16, and I have also launched an instance that ends with 200. I have created a transit gateway with the ASN 64513, and I have created the attachment from the VPC to the transit gateway. I have also established the default route for that VPC to be the attachment for the transit gateway. I replicated the same scenario on the bottom, except for the IP addressing, of course, which is different in the Sydney region. And also the ASN number for the transit gateway is different, and we consider this to be a best practice, more than anything for future-proofing our solution. I have also created a transit virtual interface. This one I created from an account where the Direct Connects reside, but I assigned that transit virtual interface to my own account where I will be deploying, where I have deployed these resources. So in the demonstration, we will see how I can accept that transit virtual interface and start working with it. And our aim at the end of this demonstration is to create the Direct Connect gateway, attach it to the transit virtual interface that we will have accepted. We will create the attachment to the transit gateway on top in the airline region. And we will also create the inter-region peering with the transit gateway on the bottom. So at the end of this demonstration, basically what I would see is that I can perform a ping from this customer router to this instance and to this instance as well, in order to guarantee that we have global connectivity. Having said so, let's jump right into the demonstration. So here I am in the AWS console, and here what I will do first is that I will check what region I'm in. Here I'm in Ireland, and we mentioned that the first thing that we would do would be to accept the virtual interface. So I move on to Direct Connect. And I click on virtual interfaces. This is a virtual interface. It's on VLAN 899. It's a transit virtual interface, and it's still in confirming state, and that is because it's been proposed to me, but I have not yet accepted it. So what I need to do is to go to this interface and accept. When I try to accept, it will request for me to attach it to the Direct Connect gateway. However, I have not yet created it, and that is why I need to create a Direct Connect gateway. When I create my Direct Connect gateway, I'm going to call it a Global Network Direct Connect Gateway, and the Amazon site ASN will be the 65030, because that is the one that I had defined in my demonstration, in my diagram. So here I create a Direct Connect gateway, and it's now available. So the next thing I need to do is to create a virtual interface, or to accept the virtual interface. And this time I will have a Direct Connect gateway that I will be able to associate it with. So I accept the virtual interface. And now that virtual interface is already in the process of being configured. So what I have done so far is created this Direct Connect gateway and linked it to this transit virtual interface. The next thing I need to do is to get into this Direct Connect gateway and create an attachment to the transit gateway. So currently there are no gateway associations because I have not attached anything to it, but I will decide to attach the transit gateway from the airline region. As I mentioned, the Direct Connect gateway is a global construct, so you can see that I actually could be able to attach it to the transit gateway in Sydney as well, but for the sake of this demonstration, I will attach it to the airline region. Here is where I will place my prefixes that will be announced towards on-premises, and what I've decided is to just say 10.0.0.0/8, and the reason why I have chosen this CIDR is because it summarizes the VPC CIDRs of 10.1 and 10.2. So instead of putting two routes, I will just put a single one in order to prevent getting to the limits sooner. So I will associate the gateway, and well, let's just double check. And the gateway association is in place. We have the allowed prefixes, and it all seems to be working correctly at the moment. And there are some configuration going on in the background. So this is there are still some steps to perform. Okay, the next thing I need to do is to go to the transit gateway. I can go to the transit gateway in the Ireland region, or I could go to the one in the Sydney region. It doesn't matter, because what I'm going to do is to create the peering connection. So Here what I need to do is to create an attachment. And I will create a Transit Gateway attachment, and I will call this attachment the first thing I need to do is to choose what Transit Gateway, and since I am in Ireland, there is only one Transit Gateway that I have here. I'm going to choose the attachment type as peering connection, and the name tag, I will call this attachment to Sydney. This is in my same account, so I don't have to enter anything else. And the acceptor, the Transit Gateway ID will be this one, which I had previously copied, but you can find if you go to the Transit Gateway configuration. So this happens to be in Sydney, and here I can create the attachment. Okay, so the request has succeeded, but you can't, in order to attach or to create an attachment, you also need to establish or to accept that attachment itself. We can see that if we go to the Sydney region, we will have an attachment that is being created and that requires my authorization in order to be allowed. So let's go here, and we can see that it's pending acceptance. So in this case, what I need to do is, this is from a former test, so as you can see, this one in the middle is already deleted. But this one, I'm going to call it attachment to Ireland for future reference. And I need to accept it, because it's been proposed to me, but I need to accept it in order for the attachment to be successful. So it's now been accepted, and the state is pending. So we're going to be waiting here for a few minutes. But in the meantime, there's something that I want to do, and that is to download the configuration for the router on premises. So this customer router we have not yet configured, and this is what I need to do at the moment. So what I'm going to do is to download the configuration for this interface in particular, which I created. And I can download the sample configuration here. So I will download this. I will open it up, and I will get rid of anything that is not relevant to me. So this is not relevant. This piece is also not relevant, and this piece is also not relevant. The rest I do leave just as it is, and I will just adjust the interface naming, because this is what will match my router configuration. So here I copy this configuration, and I can now move on to the router in order to perform this configuration. So I am now getting into the router. Okay. And now I can see that show run. Let's see if there is any configuration for BGP at the moment. And we can see that there is no existing configuration for BGP. So what I do here is just to go into configuration mode, and I will paste what I just copied. Okay. So this is all pasting, and what I'm going to do now is I'm also going to tell BGP to start advertising a default route. So this is a default information originate and network. Excellent. So this will tell the router to start advertising a default route, and we can go back to our transit gateways and see if there is anything that is being, if the attachments are already live. So here in the case of Sydney, we can see that it's pending. And let's see, and it's still pending. And in the case of Ireland, that must be the same. So that must still be getting configured. And here we have Ireland. So while this finishes, I just want to show how it would have been configured, the transit virtual interface. So give me 1 second. These two are still pending and should soon be available. But I want to take advantage of this time to tell you how the virtual interface was configured, because this is something that I did prior to the demonstration. And basically what you need to do is to go into the account that has a Direct Connect connection to create a new virtual interface, and then choose Transit as the type of virtual interface. You will also have to give it a name. In this case, I chose Global Network Transit VIF. You will choose a connection, and you can choose to have it in the same account or to have this VIF on another account. In this case, since I wanted to give this Transit VIF to the account where I deploy the resources, I chose another account, and I chose the VLAN and the BGP ASN that match my my design. So here it's A99 and 65020 and 65020. So you can see that this is the VLAN A99 and the 65020. So let's go back and see if this is already being accepted or available. Okay, here we see that the attachments are now available. And the fastest way or the easiest way that we can see something here is that if we go to the routing table, and we are in Ireland again, if we go to the routing table, we see that we are already receiving a default route. And this default route is being received by Direct Connect Gateway, and it's being propagated, which means that it basically was received via BGP. I also have this attachment, which is directly through to the VPC, and that I had already performed before I started the demonstration. But one thing I need to add is to create a static route that points traffic going to 10.2.0.0 towards the transit gateway in the Sydney region. So here I need to simply put 10.2.0.0/16, and I'm going to choose the attachment, and this is the attachment to Sydney. So once I have the attachment to Sydney ready, I can create the static route, and the static route was created. The only thing that is missing now is to go to the transit gateway on the bottom and place a default route towards the transit gateway on the top. And that is because this one is getting the route propagated by the Direct Connect gateway, but this one is actually not getting any route propagated. So we're going to establish a default route in the Sydney region. And here we are basically going to say 0.0.0.0. So we have the routes, and we're going to create a static route. And this is 0.0.0.0/0, and we're going to direct it towards the attachment that is the attachment to Ireland. And we create a static route. Okay? So the next thing that we need to do is to do the test of fire and see if this is actually working. So what I need to do is to ping the different instances, and the instances are 10.1.1.200 and 10.2.1.200, and let's see if this works. So this one is working, which is a site in Ireland, and then we can ping 10.2.1.200, and this is a site in Sydney, and we can see that it also is successful and with a larger delay because it's traveling around the world. So with this, I'm finishing my demonstration, and it's time to move on to the Q&A.